Hey guys, okay, so we're gonna go over operations with scientific notation. Some of you guys were telling me in my blue class that you want to go over multiplication and division more. So this right here, when there are two parentheses right next to each other and there's no operation in between, that means you are multiplying them, okay? So when you multiply your exponents, when you multiply scientific notation, that means you are multiplying your coefficients here. You're gonna do that first. So you have 7.9 times 9.23. We're going to find out what that's equal to. So I have, let me check out my calculator here. Calculator, 7.9 times 9.23. Okay, that gives me 72.917. My second step is to add my exponents. So remember with your laws of exponents, when you have two bases, which is the number tens, right, that are exactly the same. So these are bases here. They're the same and they're being multiplied by each other. That means that you just have to add your exponents. So that is a rule, plus -6. So you're going to follow that same rule with scientific notation, okay? So -5 plus -6, they're same sign, so you add and keep them, is equal to -11. So now that you have 72.917 and 10 to the -11th power, you're going to join your answers, which is 72.917 times 10 to the -11th power. All right? This is your answer. However, a hint that we always tell you guys is make sure your answer is always in scientific notation. 72.917 is not scientific notation. Okay, scientific notation numbers are always between 1 and 9.9999, blah, 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 blah. Okay, 72 is not one of them. So what you need to do is you need to move your decimal over until you get in between numbers 1 and 9. So in this instant, this decimal's here. I'm going to move my decimal to the left, which means I have 7.2917 times 10 to the, whenever I move my decimal to the left, that means I am adding to my exponent. So that means I'm adding a 1 here because I moved this over once. That gives me -11 plus 1, different sign, subtract. Take the sign of a higher number. My answer is -10. Okay? And this is your answer. Okay? If there's any steps in here that's confusing for you guys can message me on Remind, type it in Google Classroom, send me an email. Doesn't matter. Let me know and I'll help you. Okay? We're going to go on to the next one. We have 8 times 10 to the 5th power times 9 times 10 to the 2nd power. So again, you're going to multiply your coefficients first. 8 times 9, I don't need a calculator for that. I know that that answer is 72. And the next part is you are adding your exponents. So it's 10 to the 5th power plus 2, which is going to give me 10 to the 7th power. I got to combine my answers, which is 72 times 10 to the 7th power. Is this in scientific notation? No, it is not, because 72 is not in between 1 and 9, which means my decimal's right here. I have to move it over once to the left, which gives me a 7.2 times 10 to the, again, we are adding to our exponents by the number 1 because I moved it over 1. So 7 plus 1 gives me an 8. This is your answer. Okay? Moving on again. You got division now. This is going to be my division sign, guys, because I couldn't find a nice one. So my slash right here is the division. So I have 2.5 times 10 to the 4th power divided by 3.11 times 10 to the 3rd power. Same rules as multiplication, except this time you are dividing, okay? So you're going to divide your coefficients first. So you're going to divide 2.4 divided by 3.11, which is did I say 4? It should have been 5. 2.5 divided by 3.11, which is going to give me, I have no idea, so let's find out together. 2.5 divided by 3.11. Whoa, okay. I usually give you guys pretty numbers, okay? So I'm going to round this up to the third number. So I'm going to round it to 0.804. 0.804, okay? And my second part, same thing as multiplication, except with your laws of exponent, when it comes to dividing numbers that have the same base but different exponents, you're supposed to subtract, okay? When it comes to multiplication, you add. When it comes to division with exponents, you subtract. So 4 minus 3 is going to give you a nice, beautiful 10 to the first power. So if I combine my answers, I have 0.804 times 10 to the first power, which is this in scientific notation? No, it is not. It has to be between numbers 1 and 9. So this time, instead of moving it to the left, that'll make it further away from 1 and 9, right? So I would have to, I don't know what I just did, you guys. I would have to, I feel like I just messed up my screen and it's bothering me, you guys. All right, so this originally, I don't know what happened before I did that, is 0.804 times 10 to the first power, guys, right? Okay, again, I need it between numbers 1 and 9. So this time I'm going to move my decimal over to the left. So it's going to be 8.04 times 10 to the, whenever you move your decimal to the right, it is the opposite, okay? When you move it to the right, you are subtracting from your exponent, okay? So I'm going to subtract a 1 because that's the rule, and it's 10 to the 0 power. That seems like it's wrong. Give me a second. Let me go over my answer. 4 minus 3 is 10 to the first power. That gives you 0.804. 8 point blah. Nope, that's it. That's the answer. Okay, let's keep going. The next one we have is 9.4 times 10 to the negative third divided by 6 times 10 to the negative second. All right. Again, what do we do first? You need to divide your coefficients. So you're doing 9.4 divided by 6, which gives you what? 9.4 divided by 6. It gives you, that. 1 point, let's just round it. 1.567. Let's just do that. Okay? And again, when it comes to division and your exponents, you are subtracting your exponent, so minus a negative 2. Okay? Again, a lot of the times you guys should not get this wrong, but you are KCOing, okay? Negative 3 minus a negative 2. You keep, change, opposite. Keep your 3 the same. Change that into a plus sign. The opposite of negative 2 is positive 2. And now you guys know how to solve this using the integer song. Negative 3 plus 2 is different signs. You subtract, take the sign of the higher number, and you get your right answer, okay? So we'll have to the negative first power. I combine my two answers. So my answer is 1.567 times 10 to the negative first power. Right? Let's keep going. This one is adding. For some reason, you guys are much better at adding and subtracting than multiplication and division. But let's go over it just in case. So with adding, you cannot add your coefficients unless your power of 10s are the same. This power of 10 is a 6, and this is a 3. They both need to be the same. So what I told you guys before, I always want you to pick the smaller one to change into a larger exponent because it gives you one less step to do. Okay? So what I want you guys to do is, actually I'm going to erase that, and I'm going to put this down here. So this is going to turn into 10 to the fourth power, meaning we are adding a 1. And whenever you add to your exponent, that means you're moving your decimal to the left. This is in your interactive notebook as well, guys, okay? So that means this is going to be 0.46, and we're still adding it to this one up here, which is a 2 times 10 to the 6th power. Is this thing bothering you too? Because it's bothering me. All right, that means my tens powers are both. I'm a fool. I'm a fool, and woman's clothes. All right, I did 3 plus 1, which gives me 4, right? That's great, but I need it to equal to 6. So you see how I made that mistake? Some of you guys are probably shouting, "Say you're wrong." Blah, blah, blah. Stop. Don't worry, I caught it, guys. Don't worry. So I needed to get to 10 to the 6th power, which means I need to add 3, which means this person right here needs to move the decimal 3 times over. So I need it 1, 2, and 3 times over, which gives me point. You see these 2 spaces here? That means 2 zeros goes in those spaces. 0, 0, 4, 6, yikes, times 10 to the 6th power. That's a very ugly number, you guys. I know, I'm sorry. But now that means my final answer. These are both now 10 to the 6th, which means it stays the same. And we're going to get to add our coefficients now. So 2 plus 0.0046 is, in case you guys don't know it, 2 plus, you guys can always use a calculator, 0046 is 2.0046. 2.004 and a 6. Okay? All right. Let's move along to this question right here. We have another adding question. So again, you look at your 2 powers, they are not the same, and the higher power is a -2 this time, because remember, whenever you look at a number line, whenever the exponent is negative not exponent, I mean number. Whenever you have a smaller number, the higher it actually is when it comes to negative. So what you have is this -3, you want to change it into a -2. Okay, which means you're adding a 1. Okay, so when you add a 1, that means you're moving to the left. Miss Tucker's here, you guys. Say hi. I'm screen recording for tomorrow. All right, 0.09. Sorry, just 0.9. And now that you have the same bases, that means you get to add your coefficients, which is 0.9 plus 6.47, which will give you 5.823 times 10 to the -2nd power, which is in scientific notation, which means it's beautiful. You do not have to change it. All right, next one. Again, same thing as adding and same thing as adding. You do in subtracting. You find your tens base first, and you want to make sure that they're exactly the same. So again, like I told you before, I always want you to pick the smaller exponent and make it larger, because it gives you one less step at the end. So I added 2 here, which means I need to move my decimal place over twice to the left, which gives me a 0.05. Now this and this are both the same, which means I can add my coefficients, which is 2.23 plus 0.05. If you guys are wondering where I got my coefficients from, one is here, one is here. Add them up. Okay, that gives you 2.28 times 10 to the 8th power, because again, your bases stay the same when you're adding and subtracting.